Hey, this is Mrs. Radigan with a lesson on normal calculations, section 2.2-2. In the last lesson, we talked about density curves and specifically normal distributions or normal curves. We talked about the fact that a density curve has an area of 1 under it, and a normal curve would be symmetric, and it would have an area between negative 1 and 1 standard deviation of 68% of the total area, between negative 2 and 2 of 95% of the total area, and negative 3 and 3, 99.7% of the area. The question we're going to answer today is, how do you find areas in between those values? So in order to do that, we're going to use a z values and corresponding table, which tells us the proportions of any distribution, not just between negative 1 and 1 or negative 2 and 2, etc. We're also going to be able to go backwards, so we're going to find a z-score from a percent using the table in the opposite way. So the first thing we're going to talk about is a standard normal distribution. We talked about a normal distribution having a symmetric shape and having some mean and standard deviation. But when we add normal or standard to the normal distribution, we specifically mean a curve that has a mean of 0 and a standard deviation of 1. So remember, the z-score standardizes all the values in a distribution around the mean being 0 once the numbers are standardized, meaning at the 50th percentile. And then every set percentile corresponds to a specific z-score. That can be found using what we call a normal table or a standard normal table. So if we standardize the values and we know how many standard deviations from the mean they are, we can find the area under the curve. So for example, if we knew that we were 0.81 standard deviations above the mean, we would go to the standard normal table and we would use the column for the 10th spot of the z-score and the row for the 100th spot of the z-score, and we would map 0.81 to 79.1% or 0.7910. So that means 79.1% of the area of the curve would fall below a z-score of 0.81, or 78% of the curve would be left of 0.8 standard deviations above the mean. So in these next examples, we're just going to practice using the tables to find the percent of the curve that is left or right or in between some z-score values. So this first one, we are saying we want what percent of the curve lies below a half a standard deviation above the mean. In this one, we're saying we want to know what percent of the curve lies above 1.12 standard deviations below the mean. So we're going to use the standard table, and we'll go ahead and do A first, where we're looking for the z value of 0.54 and its corresponding percent. So we go to, there's negative values in a z table, and then there's positive values. So we want 0.5, and then we go over to the tenths column of 4, and we get 0.7054. So the area under the curve to the left of half a standard deviation above the mean is 0.7054 or 70.54%. We're going to do the same thing for this one, but it's a little more complicated because remember, the table always talks about the area to the left. So when we look at the z-score of negative 1.12, it's going to give us the percent corresponding to this unshaded area. So in order to find the area on the other side, we would, you guessed it, subtract this tiny piece from 1, and that will give us the green area. So we go to the negative z-score table, negative 1.12 2 would be a value of 0.1314. And that is going to give us a z-score of, or a percent when we subtract it from 1, of 8.8686 or 86.86%. In part C, we want greater than 3.89, so basically above almost 4 standard deviations from the mean. We're talking about almost nothing out there under that curve, and if we look at the table and we go to the positive z values, we see that 3.49 is the highest that they go, basically because that is almost 1.9998. So if we're talking about the area to the left of the curve, we're saying this unshaded area is almost 1, which would leave the shaded area basically at 0%. In the next one, we want to know how much area is between a half a standard deviation and 1.82 standard deviations. So what we're going to have to do on this one is we're going to have to figure out how much is left of 1.82, how much is left of 0.49 standard deviations, subtract the red from the blue, and that'll leave us with the green area there. So we go to the table and find 0.49 and 1.82. So 0.49 is all the way over here at 0.6879, and 1.82 is right here at 0.9656. So we're going to take those two values and we're going to subtract them, and that'll give us 27.77%. Similar to Part D, Part E says within 1.5 standard deviations, so that means 1.5 below to 1.5 below, above in the area here. So we're going to need to find the area left of negative 1.15 and subtract it from the area left of 1.15. So we have to go to the negative table, negative 1.5, and we get 0.0668. And then we have to go to the positive table, 1.5, and we get 0.9332. We just go ahead and subtract those two values, and we see that we get 0.8664 or 86.64%. In this next section, we're going to be working backwards. So what does that mean? It means that given the percentile, we're going to go ahead and find the z-score using the table in the opposite way. So let's say that we know this area here shaded is 70%, and we want to know how many standard deviations above the mean we are. Since we know 50 is 0, we know we're above the mean at 70%. So we go ahead and look through the table, and we see we have 50s and then 60s, and here we're getting into the 70s. So right about in between these two values would be 70%. So we just go over here and we see that it's 0.502 or 0.53. So somewhere between 0.52 and 0.53 would be the z-score. So about a half a standard deviation above the mean gives you 70 percentile or 70% of the data below you. So if we look at these two working backwards problems, in this one, this first one, it says that Joe scores at the 85th percentile, and we want to know how many standard deviations above the mean did he score. So we're going to go ahead and look at the table and look for 85%. So we have to go somewhere around here. So basically in between these two, which would be 1.03 or 1.04. And we'll just go with 1.04 since it's 0.8508%. So we say that Joe scores 1.04 standard deviations above the mean if he's at the 85th percentile. Same thing with the next example. It says how many standard deviations below the mean is Q1. So remember, Q1 corresponds to the 25th percentile. So we're going to go back to that table This only goes to 50, so we need to go up into the negative z-scores, and that will give us from basically 0 to almost 50 percentile. And we're going to look for the 25th percent. So we got to go down here, and we're getting closer, so around right here. So that is 0.6, and then we're basically at between 0.07 and 0.08. So we would call that about the 0.67 or 0.67 standard deviations below the mean is where Q1 is at. Okay, in this last example, we are going to try to apply this to a little bit more real world here. So it says in 2008, Rafael Nadal averaged 115 miles per hour on his first serves at the Wimbledon tennis tournament. We're going to make the assumption that his distribution is normal with a mean, an average of 115 and a standard deviation of 6. We're going to answer quite a few questions here, the first one being about what proportion of his serves would you expect to be slower than 103 miles per hour. So when you answer a question like this, you always want to go through 3 steps: stating the distribution and identifying the values of interest. So to state the distribution, we want to state that it's a normal distribution with a mean of 115 and a standard deviation of 6. Then we need to state what we're finding. So we're finding what percent of the serves are slower than 103 miles per hour. The next thing we want to do is go ahead and show our work for finding the z-value, showing where that is on the curve, and then finding the actual z-value in the table. So remember, to find the z-value, we take the value, which we said slower than 103. First, we want to state the distribution. So it's a normal distribution with a mean of 115 and a standard deviation of 6. And the question, what percent of the serves are slower than 103 miles an hour? Then we want to show our work to find that percent. So we first find the z-value by taking that value minus the mean divided by the standard deviation. We get 1.5 standard deviations below the mean. And then we find the corresponding value on the table that goes with negative 1.5 standard deviations. And lastly, we answer the question in context. So 6.68% of the serves would expected to be below 103 miles per hour. The next question asks us to find what are the expected percent to be above 120 miles per hour. So we do the same thing where we find the z-value. 120 minus 115 over 6 is 0.833. So 0.833 standard deviations above the mean is about 79% to the left. So we have to take 1 and subtract that in order to find the area in the green, which is about 0.2033. So 20.33% of the serves would be expected to be above 120 miles per hour. The next one is between two values. So just like we did on the other ones, we're going to be finding two z-values and 2 percents. We subtract the little percent from the big percent so we can get the net green here. So we find the z-score of 100 to be negative 2.5, the z-score of 110 to be negative 0.833. We find those percents, so 0.6% down here, 20% this whole thing to the left. We subtract them and we get 19.71% would be in the green area between 100 and 110. The last question is a working backwards question. It says the fastest 30%. So that means the top 30, but remember our table tells us to the left, so we want to find the z-value at the 70th percentile. That would be a z-value of 0.525. We then plug that value into the z formula and we solve for the value instead of solving for z. So we do some algebra here to multiply by 6, add 115, and we get a miles per hour of 118.15.